Okay, simplifying surds. What is it all about? Simplifying surds basically just means that the number underneath the root sign has no square numbers as factors. Okay, so importantly, write the square numbers. Let's make a note of the first few of them. We've got 1, 4, 9, 16, 25, 36. That should be fine for the time being. Right, if you can rewrite your surd, so for example, if you were told to simplify root 50, okay, if we can write this as the root of two numbers multiplied together, okay, so the product of two numbers where one of them is a square number, okay, we can simplify it. And root 50 can be written as the root of 25 times by 2, because 25 times by 2 is equal to 50, and importantly, right, 25 is a square number, which means using our surd law, which we know hopefully quite well by now, which is root A times root B can be written as root A times by B, all rooted. Okay, we proved that last video. We can then go and say that, well, this below can be written as the root of 25 times by the root of 2. Okay, and well, root 25 is equal to 5, so we can write it as 5 times root 2, or 5 root 2. So this here is your answer. So root 50 is exactly the same thing as 5 root 2, just this is simplified, okay, because you've got rid of that square number, okay, by simplifying it down. Okay, it just becomes easier to work with simplified surds. So that's what simplifying is. Okay, so we'll go through some my turn, your turns, starting off quite simple, and then we'll get a little bit harder. So the first two, right, simplify the following, root 32. Okay, so again, if you need to make a note of your square numbers, which are the first few, okay, that we're going to need, probably that's going to be absolutely plenty. Okay, root 32, we can write it two numbers that times make 32, where one of them must be a square number, 16. We can write 32 as 16 times by 2, which is 32, and we can break it up into two separate surds. Root 16 times by root 2. Root 16 is equal to 4. 4 times by root 2 we can write as 4 root 2. This is your answer, okay? Root 32, the same thing as 4 root 2. We've just simplified our answer. Okay, this one, very similar. We've got 2 root 32. What does this really mean? Okay, well, 2 root 32 means you're doing 2 times by root 32. And we know previously that root 32 is equal to 4 root 2. So I can just replace this with 4 root 2 and say I've got 2 times by 4 root 2. Okay, well, 2 times by 4 is equal to 8. So it's going to be 8 root 2. So 8 root 2 is your answer there. Okay, and that is it. Let's highlight this. Good. Excellent. Okay, so you can try the two your turns yourself, and then we'll go through them now. So hopefully you've had a go at those. Let's go through them now. The first one, root 72. Again, two numbers that multiply to make 72. It's going to be 36 times by 2. So we can write this as 36 times by 2. Okay, and again, you can break it up into two surds. Root 36 times by root 2. Root 36, of course, is 6. So you get 6 root 2 as your answer. There we go. Below, we've got 5 root 2. What does that mean? That means you've got 5 times by root 72. And we know that root 72, okay, this is the same thing as 6 root 2. So we can go and put in 6 root 2 into here. 5 times 6 is 30. So 30 root 2 is your answer. Excellent. Okay, some slightly trickier ones now. So we've got these two surds here. You definitely, right, when you want to work out this, root 50 add root 32, you cannot, that is not the same thing as just doing root 82. You can't just go and add your numbers together. That is an illegal move with surds, okay? But what we can do when you want to simplify this, if you can get the surd part to be the same, okay, you can then add them together. So you want the part in the surd to have the same number, because then effectively you've got like terms going on. Root 50, how can you write root 50? Well, root 50 can be written as root 25 times by 2. Okay, and as we get more familiar with this, we can kind of go straight to it. So root 25 is equal to 5 times by root 2, so 5 root 2. Okay, I've just skipped out the parts where I wrote it. This bit and this bit, I've just gone straight to this part. Okay? And then, right, hopefully with root 32, I can break it down. So my surd part is going to be a root 2, and I can because root 32 is the same thing as 16 times by 2. And of course, root 16 is equal to 4 root 2, so 4 root 2. So root 50, okay, is equal to 5 root 2. So I've got 5 root 2 and I'm adding to that root 32. We've just seen that root 32 is the same thing as 4 root 2, so 4 root 2. And then this is a bit like if you had something like 5x add 4x, okay, you'd get 9x, the same thing here. You've got 5 root 2 add 4 root 2 is going to be 9 root 2. Because literally going on, you've got 5 lots of root 2, you've got root 2 added to itself 5 times, and you're adding on 4 more. Okay, a bit of a long one to write out, but that's literally what is going on behind the scenes. So you can see overall, 5 add 4, you get 9 root 2 as your answer. Good, so the key thing is if you're adding or taking away surds with different numbers initially, you want to break it down so the surd parts, we've got a root 2 here and a root 2, you can combine them together. Okay, so root 20 and root 45, you can try this one. Root 20, how can you write that? You can write this as 4 times by 5. Root 4 is equal to 2. Root 5, so 2 root 5. You've then got root 45 is equal to root 9 times by 5. Root 9 is of course 3 times by root 5, so 3 root 5. Root 20 is going to be therefore 2 root 5. Add root 45, which is the same thing as 3 root 5. 2 with 3 is 5, so 5 root 5 is your answer. Okay, so this is one purpose, one use of being able to simplify surds down, because you can add surds together. Okay, let's look at some more trickier examples, but really it's the same kind of idea going on again here. So here we've got 8 root 3, take away root 27, add root 48. You want the surd parts to have the same number in them, because then you can combine everything together. So let's go and look at, first of all, well, root 3 you can't break down any further because root 3 is a prime number, so we can leave that one. Root 27, we can definitely break this down because root 27 is equal to root 9 times by 3. So root 9 is equal to 3 times root 3, so 3 root 3. Root 48 is equal to the root of 16 times by 3, where 16 is, root 16 is 4, so it's going to be 4 times root 3, 4 root 3. So overall, okay, we've got 8 root 3, let's go and do it in blue. We've got 8 root 3, take away root 27, and root 27 we've just seen as 3 root 3. So take away 3 root 3 plus root 48. Root 48 is equal to 4 root 3. So plus 4 root 3. And then we can just go and add the number parts. We can go and do 8, take away 3 is 5, add 4 is 9. So overall it's going to be 9 lots of root 3. And this is your answer. Okay, you can try this one. Again, similar method, get the roots to be the same number, and then you're good to go. Well, you can see here we've got a root 2, which is a prime number, so we can't break this one down any further, so you know you want to get a root 2 underneath your surd sign. So root 18, okay, if we go and break this one down, first of all, root 18 is equal to root 9 times by 2. Root 9 is 3, so 3 root 2. This one, we can't break it down because root 2 is a prime number, but root 200, we can of course write it as root 100 times by 2. Root 100 is 10 times by root 2, so 10 root 2. Therefore, overall, we're going to be getting root 18, which is the same thing as 3 root 2. Take away 5 root 2, keeping it the same. Root 200 is the same thing as 10 root 2, so plus 10 root 2. And again, you just look at your number parts. We're doing 3. Take away 5 is negative 2. Add 10 is equal to 8. So overall, we've got 8 lots of root 2. So 8 root 2 is your answer for this one. Okay, and that is it for this video. That is it on simplifying surds and looking at one use of actually simplifying surds, because then you can add and subtract other surds together, but you will see there's many other uses of simplifying surds in latter videos. Okay, thank you.